Hi, welcome to the lesson on measures of relative standing. Another way of saying that is measures of position. So it can be useful to compare one observation to the rest of the data set. So for example, how did you score relative to the rest of the class on the test? Or how tall are you compared to everybody else of your age? So we're going to look in this section at three different tools in examining position. Two ways of measuring position are percentiles and z-scores. We'll talk about those. And then we'll also look at outliers, which is a way of saying that your position is really far away from everybody else. So let's start with percentiles. The kth percentile of a data set, k can be any number between 1 and 99. The kth percentile of a data set is the value with that percent of the data below it. Now, it's not below or equal to it, it's just below it. So the 25th percentile would be the data value that's higher than 25% of the data. So there's only 25% of the data that's below that. So if you are in the 25th percentile height-wise, that means that you're taller than 25% of people, which means you're on the shorter side. There's no such thing as the 100th percentile because of the way this is defined. This is always defined as below, not below or equal to. So the highest observation in the data set can't possibly have 100% of the data below it because it's part of the data set. The only exception to this is rounding, but we won't get into that. There are some common percentiles we'll see. The 25th and the 75th are considered quartiles, Q1 and Q3. The 50th percentile is the median. And there is something that you'll see from time to time, the IQR, which is the interquartile range, which is, if you pick that apart, it's the range. Inter means between the quartiles. So it's just Q3 minus Q1. So it's the 75th percentile minus the 25th percentile. That itself is considered to be sometimes a measure of spread. All right, so let's look first at percentiles. So I've got this data set for us to use, which is waiting times at a doctor's office. Collected data from, I think it's 12 different people who were waiting different amounts of times at the doctor's office. So the first one we want to do is find the percentile of a person who waited 5.47 minutes. And literally all you have to do is go through and count how many observations are below 5.47. So we've got 1, 2 out of 12. So 2 out of 12, and convert that to a percent. It can make it easier sometimes, especially if you're looking at a larger data set, and you will. It can make it easier to sort the data. So I've sorted the data here. So just from least to greatest, we've got 2 observations that are less than 5.47. Out of, there are 12 total. Convert that to a percent. We get the 17th percentile. Okay. Different textbooks will tell you some different details on calculating these. Let's just do it this way, and we'll always round to the nearest whole number. Okay, so we're just counting the number of observations that are below the thing we're looking for the percentile of, divided by the sample size, convert it to a percent, and round it to the nearest whole number. Okay, so this is the 17th percentile. Let me show you real quick, because like I said, you will be working with some larger data sets. So I have this in SPSS. So to sort the data in SPSS, you just go to Data, Sort Cases, move the variable over, and we want to sort it ascending. So click OK. When we do that, we go back and look at the data, and it's been sorted. Okay, so it makes it easy to count 2 out of 12. All right. So if you had some homework where there was a larger data set, you could still you could go in here and just very easily look at how many rows you are. This is row 3, which means that there are 2 observations below you in the data set out of, and you can see that there are 12 observations total. All right. Okay. And by the way, we can do the same thing in StatCrunch. You just go to Data, Sort, pick your variable, and click Compute. Sort by variable 1, ascending, compute. Now we can see the data is sorted from least to greatest. All right, so percentiles, that's all I'm going to ask you to be able to do. Is find the data point, count how many observations are below it, and then do that as a percent of the total. All right, so we've seen box plots briefly already, but let me talk just a little bit more about what box plots tell you. I created this box plot in StatCrunch for this waiting times data set. Here's what each one of these things tell you. The box for the box plot tells you the 25th percentile and the 75th percentile. And then you've got a line in the middle for the median. Okay, so the box represents the 25th percentile up to the 75th percentile. And then, like I said, that line in the middle is the median. The dot out here shows an outlier. There is a formula you can use to determine what data point is an outlier, but I'm going to spare you that. If you want to know, let me know. I'll tell you. And then these whiskers go out as far as the highest and lowest observations that are not outliers. Okay, so we take out this outlier. The remaining data has a minimum of 3.82 and a maximum of 10.49. Okay, so it can be really nice to look at box plots because you can see the outliers. So again, we can see from looking at this box plot, the middle 50% of the data is between 5.55 minutes and 8.36 minutes. We can see what the median is at 6.035. We can see there's an outlier at 1, and then we can see, other than the outlier, what the min and max data points are. Here's the same box plot in SPSS. And I want to point out here, this number never tells you what the data value is. That number represents what row the data is, what row that data point is. So let me show you how I got these. We'll do StatCrunch first. So if we go to Graph, Box Plot, pick our variable, and that's good. We want to make sure it's checked on Use Fences to identify outliers. Click Compute. that shows us our box plot. That's the same one I pointed to. And over here in SPSS, we've done this before, but we just go to graphs, analyze, descriptive statistics, explore. We pick our data point. And if we just want the plots, click plots and we'll click OK. Here's our box plot. Now you may notice that here this one is labeled with a 1 as opposed to a 12. That's because when I sorted the data, this data point was the first data point on the list. Previously, before I sorted the data, it was the 12th one, so it was in that position. Okay. The reason they do that is they think it might be useful for you, and they're right. It might be useful for you to go back and look at the data so that if you have an outlier, you can kind of look through the data points and see, what's going on here. Why was this an outlier? All right, so that's box plots and outliers specifically. By the way, it's a good question to ask, what do you do with outliers? If you find an outlier, what does that mean? You throw it out? Some people automatically want to throw it out. But the statisticians usually recommend that you don't throw them out unless you think or know that it's a mistake. So if this person who waited 1 minute, if we recorded the data point wrong and it should have been 10 minutes, we would throw that out. We don't always know that it's an error, but it might be. If we get something that doesn't even make sense, if it said 10 hours, then that's clearly a mistake. I've seen examples where somebody says that they watch 30 hours of TV per week, when what they really mean is 30 minutes, per day. 30 minutes of TV per day. Clearly somebody doesn't watch 30 hours of TV per day. So there's some things that we can clearly see are errors. Unless it's an error, unless it's clearly an error, don't throw it out. All right, finally, let's talk about z-scores. Z-scores tell you how many standard deviations above or below the mean an observation lies. So an observation can have a negative z-score if it's below the mean. It'll be 0 if it's equal to the mean exactly, and if it's above the mean, it'll be positive. And the formula is just x, and x is the number that you want to find the z-score of, minus the mean divided by the standard deviation. And I didn't specify mu and sigma here, or x bar and s, because it can be for the sample or the population. So let's do a quick example. So we know that in the U.S., men have a mean height of 69.1 inches, and here's their standard deviation. Women have a mean height of 63.7 inches, and here's their standard deviation. And we want to use z-scores here to determine if you've got a 65-inch tall man and a 62-inch tall woman, who's taller relative to others of the same sex. So if you took a 65-inch tall male, 65 would be x, and then you'd subtract the mean. So the mean for all men is 69.1, divided by the standard deviation for men is 2.9. You do 65 minus 69.1, and then divide the result by 2.9. You get negative 1.4138. And then if you do the same thing for females, do 62 inches, because This is the woman that you want to find the z-score of. Subtract the mean height for all women, divide by the standard deviation, you get negative 0.6296. And I just want to make sure that you've seen me do this for one of these. So 65 minus 69.1. People can make mistakes here with order of operations. So make sure you hit enter and then divide by 2.9. So we get negative 1.4138 for that first one. All right, so if you look at the two scores, the male's z-score is more negative, so it's lower than the female's. So he's the shorter of the two, relative to others of the same sex. All right, so that's it for this lesson, and as always, let me know if you have any questions.